In this video, I'll solve a problem about a hockey puck that is hit with a hockey stick for a brief period of time at a very high force. So I will do this two ways, once using kinematics and the other way using momentum. So as usual, we start by drawing a picture, doing knowns and things we need to find. So we've got a hockey puck. It said it was 170 grams. I don't like grams. I want to go automatically to SI units every time I start a problem. So I went ahead and switched it to 0.17 kilograms. It's initially moving at 23 meters per second, and then there's this collision with the hockey stick. And in that collision, the hockey stick applies 2,000 newtons. So externally, if our system is just the puck, this is now the external force of the hockey stick acting on that puck, 2,000 newtons, makes it now go 36 meters per second. Mass stays the same. So we know the initial velocity, final velocity, the mass, we know how much force it is. The question is asking how much is the time that the stick is in contact with the ball. So first we'll try it with kinematics. So kinematics equations, well, we've got force. Kinematics, we need velocities and accelerations and things like that. So force equals ma. Force can give us the acceleration. Look at that. So force, we know mass, we know what the force is. So acceleration is the force over the mass. So that's 2,000 newtons over 0.17 kilograms. That's got to be what the acceleration is. Acceleration is a vector. What direction is that force? Well, if something's moving this way and then it's moving faster that way, it means it accelerated that way, so the force must have been in the x direction. Alright, so that's the acceleration. So we have that. But we're not looking for that. We're looking for time. We also have initial and final velocities. So acceleration is a change in velocity over a change in time, right? So a change in time is change in velocity over acceleration. Just multiply both sides by delta t, divide both sides by a. So that is v final minus v initial over a. Delta t is 36 meters per second in the x direction minus 23 meters per second in the x direction over a is 2,000 newtons over 0.17 kg, also in the x direction. They're all x directions. X direction kind of cancels out here. So we get just time. So that is 1.1 milliseconds. 1.1 times 10 to the minus 3 seconds. So that's using kinematics. Now, let's try using momentum. So momentum says change in momentum is the force times the change in time. Okay, so change in time is change in momentum over the force. Change in momentum, that's mass, times the change in velocity. Now over the force, 0.17 kg. Change in velocity, that's the final, 36 meters per second minus 23 meters per second, the initial, both in the x direction, over the force is 2,000 newtons in the x direction. And if you look, this equation is the same as that one. So in this case, it took a little bit less math because we didn't have to go through acceleration. Here we had to find acceleration and use that. With this one, we didn't have to find the acceleration. So you get the same expression more efficiently by solving this problem using momentum.